Hello everyone, welcome to a new short video on solving a LeetCode problem with Dialog APL. Today we will be tackling problem 771, Jewels and Stones. So let me go ahead and see what it says. So I'm given strings jewels representing the types of stones that are jewels and stones representing the stones you have. Each character in stones is a type of stone you have. Sure. You want to know how many of the stones you have are also jewels. Letters are case sensitive, so lowercase a it is considered a different type of stone from uppercase A. Okay, and they show us some examples. So if I have these stones over here, so lowercase a, uppercase A, and then BB, then I only have 3 jewels because it's these 3. And in this particular case I have 0 jewels because uppercase Z is not a jewel. Okay, so this isn't that interesting, I think. It's just really simple. But that's fine. I mean, that was a silly remark. It's an easy problem, and the point is showing you how this works in APL. So basically what I want to do is take a look at stones, and then for each one of them I want to see if they are in the jewels string, and then I want to count all of those. And this is actually really simple. So let me go ahead and open my interpreter. So let's say these are the jewels, so it's lowercase and uppercase a, and the stones were, I think, A, B, something like that. Now what I can do is actually use the membership function, and what this says is which stones are members of the jewels. And this gives me a Boolean mask. You can see here that these 3 ones correspond to these A's, and it means that these characters appear in here, and the zeros say that the B's do not appear in the jewels. And if you know some maths, you might recognize this symbol, because this is the maths symbol for is a member of. So this is the membership function, and then what you want to do is sum these up. So you want to sum the ones. Okay, and this is actually, I think, let me see, I think you can make this a little bit more. No, you can't. Sorry, I was thinking of something neater we could do, but that won't work for this particular case. Okay, so something else you could try, maybe, and to be honest, it was my first thought as I was reading the problem, was that I would be wanting, or I would be intersecting the jewels and the stones. I thought I wanted to find the intersection between the stones and the jewels, but the intersection only gives me the unique members, and so from here I cannot count the stones. Actually the number of jewels I have, because these 2 uppercase A's get deduplicated. Sorry, I was thinking of the word I needed. So I have 2 of them in here, but when I intersect them with jewels, I only get a single one. And I do wonder what would happen if for some reason I have multiples of the jewels, and then in this case I can get the intersection to work. But if you take a look at the problem statement, it says that, where is it? Yeah, all of the characters in jewels are unique. So I can't rely on jewels having as many stones as I need. And so this is actually the simplest solution. You just sum after computing the membership. And we could write this as a diffn, so we could just say let's sum, and let's say that the stones are the left argument, so let's sum when the number of stones that are members of the number of jewels, or the jewels. So this could be our solution, and we just say, well, stones solution jewels, and we can even use this other example. So ZZ, our solution in here, we have 0 jewels, but we can also write this in a tacit form, And in order to do that, we just need to see that what we are doing is doing this plus reduction on top of the membership function. And so as a tacit solution, this is just this. You can write it like that, or I usually prefer to wrap this in parentheses because it just makes it easier for me to understand what I'm doing. And if you take a look at the solution, this is how it's displayed. And it just goes to show that this train over here, this tacit function, is being seen as these two boxes mean two different functions, so the plus reduction on top of this. Yeah, so this is basically it. I think this is the most obvious approach to this problem. So if you come up with anything really simple or an alternative solution that you think is nice, that showcases some interesting feature of APL, feel free to leave it in the comments below, or maybe make a pull request to the GitHub repo that will be linked in the description. And if not, I will see you in the next video. Bye.